Chapter 9.3, Measuring Weight and Temperature. Weight is the measure of the gravitational pull on an object. Although your weight varies depending on the force of gravity, your mass is exactly the same in all locations. Mass is a measure of the quantity of matter in an object. On Earth, as your weight increases, so does your mass. So in this section, measurements are assumed to involve everyday situations on the surface of Earth. Thus, we will treat weight and mass as equivalent. So here's our units of weight in the English system. Again, notice the terrible numbers we're forced to multiply and divide by, 16 and maybe 2,000 instead of 1,000. Also be wary of this ounce as opposed to a fluid ounce. Another very confusing thing about the English system, right? Same term used for different kinds of measure. Okay, we change units in the metric system of weight, though, exactly the same way that we change the units of length and the units of volume. So, recall we had King, Henry, danced, merrily, down, center, main. And if we wanted to convert in volume, we simply changed the meters to liters. If we want to convert in weight, we'll simply change the meters or liters to grams. Everything else is going to work exactly the same. Not only that, this is where it gets really interesting. Remember from the previous section that we saw that 1 cubic centimeter is 1 milliliter? Well, 1 milliliter of water weighs 1 gram, giving us this phenomenal conversion factor here that 1 cubic centimeter is 1 milliliter is equal to 1 gram. Wow, we can not only change back and forth in the metric system, we can change easily in the different measuring systems of the metric system. Okay, and we'll do some of that in the problems. It's very much the same. If we're going to use the English system, we're back to dimensional analysis. If we're going to use the metric system, it's just a matter of moving your decimals. And here's some conversions to change between the metric system and the English system. An ounce is about 28 grams, a pound is 0.45 kilograms, and a ton is 0.9. This is how we distinguish a metric ton. Right? Okay. Also, again, just to kind of get a feel for what it means to be a gram, so that we can not feel so alienated when we try to use this metric system. Remember when we were talking previously about a paperclip, and we said a paperclip's width is about 1 centimeter wide and 1 millimeter thick? Well, a paperclip weighs a gram. So a good point of reference there for us. Let's go ahead before we do our problems and talk about temperature. The Fahrenheit temperature scale is the one that we're accustomed to, and it was established in 1714 by the German physicist Gabriel Daniel Fahrenheit. He took a mixture of salt and ice, which was then thought to be the coldest possible temperature, and called it 0 degrees. He called the temperature of the human body 96 degrees, and divided the space between 0 and 96 into 96 equal parts. Fahrenheit was wrong about the body temperature, though. It was later found to be 98.6 degrees by his scale. So on his scale, water froze without salt at 32 degrees and boiled at 212 degrees. 20 years later, the Swedish scientist Anders Celsius introduced another temperature scale. He set the freezing point of water at 0 degrees and its boiling point at 100 degrees and divided the space into 100 equal parts. Degrees were called centigrade in this system until 1948. Think about that. Centa your metric prefix meaning 100th, right? And if he had divided it into 100 equal parts. But in 1948, the name was officially changed to honor its inventor. However, centigrade is still commonly used in the United States. So these following formulas can be used to convert from one temperature scale to the other. And they're very simple, very basic. You just plug in, if you have a degree Celsius and you want to convert it to Fahrenheit, you plug it in here, plug it into your calculator. Same thing here. If it started out with Fahrenheit, you plug it in here and plug it into your calculator. What I would like us to take away from this, more than that though, is a general idea. What does it mean to be 20 degrees Celsius? Right? If someone tells me it's 20 degrees Celsius, I'm curious, oh, should I wear a sweater? Should I wear shorts? I don't even understand that. A very good, not precise conversion factor, but a very good conversion factor is if you're given a temperature in Celsius, you can double it and add 30 degrees. So 20 degrees Celsius is doubled, gives me 40, and add 30. That's about 70 degrees Fahrenheit. Okay, I know how to deal with that. Likewise, if, let's say, you know the temperature in Fahrenheit and you're trying to convey that to a friend in the UK, how hot it is in Texas right now, it's 100 degrees, and she's like, well, what does that really mean? You can subtract 30 degrees, so that would give 70, and then take half of it and tell her, oh, it's about 35 degrees Celsius. And she'll be, oh my word, it's really hot over there, isn't it? Okay, we're going to practice that some, and I'd really like y'all to get used to using that idea. Now, because temperature is a measure of heat, scientists do not find negative temperatures meaningful in their work. In 1948, the British physicist Lord Kelvin introduced a third temperature scale. He put 0 degrees at absolute zero, the coldest possible temperature at which there is no heat and molecules stop moving. Water freezes at 273.15 kelvins, which is how that is read, and boils at 373.15 Kelvin. The Kelvin scale is the same as the Celsius scale, except in its starting point. That makes it easy to go back and forth from Celsius to Kelvin. So you just add 273.15 degrees to your Celsius temperature, or subtract 273.15 from your Kelvin. Kelvin scale was embraced by the scientific community, and today it is the final authority as scientists define Celsius and Fahrenheit in terms of kelvins. We're not really going to convert into or out of the Kelvin system, but you can't have a fair discussion about temperature scales without talking about Kelvin, since it is the final authority today. But we're not scientists, so we're going to use our common Fahrenheit and Celsius scales to convert between. However, think about this, okay? Over here, we always talk about running a 5K race. A 5K race means a race at 5 kelvins. This is a race so cold that no one would be able to move because all the participants would be frozen solid. The proper symbol for a race 5 kilometers long should be this, a 5-kilometer race. Sorry, reverting back to most of my life I called that kilometers, but we should call them kilometers. All right, let's look at some questions now. Convert the given unit of weight or measurement of water. Remember, our grams are really 1 gram of water weighs the same as the volume in 1 milliliter. Okay, so we're just being very specific there. To the unit indicated. Well, first, we're simply in metric. So I need to know that King Henry danced merrily down Center Main, and the only difference is I can make that a gram. So if I'm starting at decigrams and going 2 milligrams, here's deci. 2 units to the right to move my decimal point. 740 milligrams. Same thing. Except this time I'm starting at milligrams and going to grams. So I'm going to start right here and move 1, 2, 3 units to the left. There's my decimal. If it's not shown, it's understood to be at the end of the number. So 0.870 grams. Okay, 8 grams to centigrams. Okay, here's grams. 2 units to the right. Again, there's my decimal. It's at the end if it's not showing. So 800 centigrams. Kilograms to grams. Very, very easy to convert in the metric system. All right, kilograms to grams. 1, 2, 3 places to the right. So 18,600 grams. Okay, now we're converting into 2 different kinds of measuring systems, both in the metric system, but linear to weight. So don't forget, I know that 1 cubic centimeter is 1 milliliter is 1 gram. So I can change this to cubic centimeters. And let's do that first. All right. Okay, so I'm going from meters to centimeters. Wait, let's get rid of this. Okay, from meters to centimeters is 2 places to the right, but it's cubed, so 2 times 3 means I'm going to move this decimal 6 places to the right. So here's 2 places. I need 4 more, so 4 zeros. All right, 50,000 cubic centimeters. Well, 50,000 cubic centimeters is the same thing as 50,000 grams. And now that I'm in the metric system of weight units, I can change 50,000 grams to kilograms. Okay, I'm grams. Go to kilograms. Oh, need a pen. Kilograms. Grams to kilograms is 3 places to the left. So 50 kilograms. Very nice. Very nice. Here we are again. Kiloliters to grams. Different units of measure, liters and grams. But I can get from one system to the other very nicely. Let's start by changing kiloliters to milliliters, right? Because that's going to get me to grams. Kiloliters to milliliters. So it's the only difference, right? That is the only difference. So if I'm in kiloliters and I want to go to milliliters, that says move the decimal 1, 2, 3, 4, 5, 6 places to the right. So this is 2 places. 4 zeros need to be added again. 1, 2, 3, 4. Okay. All right. So now I have 40,000 milliliters. I changed my kiloliters to milliliters. Oh, a milliliter is a gram. I've already got that. Also 1 gram. That's 40,000 grams because 1 milliliter is 1 gram. Very nice, very nice. Okay, let's look at the English system now, or English to metric. Okay, that means if it involves the English system, dimensional analysis. And we've got some basic conversion factors here that it's asking us to use. We want to change 36 ounces to pounds. So I'm starting with 36 ounces, not fluid ounces, because I'm using dimensional analysis. I'm going to put that over 1. Oh, and I have a nice one right here. 16 ounces is a pound. Ounces must go on bottom. 16 ounces is 1 pound. So my ounces divide out, and I'm left with 36 times 1 divided by 16, or 36 divided by 16 is 2.25 pounds. 36 ounces to grams. Okay, well here I've got a conversion factor that goes from ounces to grams, so I'm going to use that one. If I have 36 ounces, I'm going to put that over 1 to get my numerator and denominator straight. And I know 1 ounce is 28 grams, so just put the ounce on bottom. 1 ounce, 28 grams. The ounces divide out, and 36 times 28 is 1,008 grams. Pounds to kilograms, they're giving you a conversion factor directly from pounds to kilograms. So 540 pounds. And I want the pounds on bottom, so 1 pound is 0.45 kilograms. The pounds will divide out, and 540 times 0.45 is 243 kilograms. Pounds to grams. Okay, when I look up here, I don't have anything that goes directly from pounds to grams. So I can either change my pounds to kilograms and then just move the decimal back in the metric system to do that, or I can change my pounds to ounces and use this conversion. Doesn't really matter. Whatever is easiest for you. Since I'm going to do some dimensional analysis, I'm just going to do all dimensional analysis. Okay, 80 pounds, I know, is, let's see, I'm trying to get to grams, so I got to go through ounces. So I know that 1 pound is 16 ounces. Now I'm in terms of ounces, and I know that 1 ounce is 28 grams. So now I'm in terms of grams. It's just dividing by 1, so all I have to do is multiply 80 times 16 times 28, 35,840 grams. Okay, what about this? Convert 35 degrees Celsius to degrees Fahrenheit. Okay, the first thing I want us to do, before we just plug into the formula, let's get an estimate. Okay, just give me a feel for what does it mean to be 35 degrees Celsius. Well, if I double that, I get 70, and then add 30. This is about 100 degrees Celsius. That's really something I want us, 100 degrees Fahrenheit. That's really something I want us to come away from this section with. Let's get an exact answer. Let's plug into our formula. And here's the formula, right? You'll be given the formula. F equals 9/5 C plus 32. I'm given the Celsius temperature, so that's why I know to plug into this one. So 9/5 times 35 plus 32. I really should know right here that 35 divided by 5 is 7. And so 9 times 7 is 63 plus 32. I shouldn't even have to pull out my calculator for that. And notice what I get, 95 degrees. 100 degrees, very good estimate. Right? 95 degrees, 100 degrees. It's all hot, right? Okay, or you can plug this into your calculator if you didn't catch the fact that that math is real easy to do right there. Just be careful with your parentheses. Okay, convert 72 degrees Fahrenheit to degrees Celsius. Well, first of all, again, what is that about? Let's say I don't need to know precisely. I don't want to pull out my calculator. If I subtract 30 degrees from that, I get 42. And half of 42 is 21. Oh, that is going to be about 21 degrees Celsius. Let's plug into the actual formula and see what it is. Here's our formula. And all I need to do is plug the 72 into the F. So 5/9, 72 minus 32. So this is 5/9 times 40. Now, 9 doesn't divide evenly into 40, so I might want to plug that into my calculator and see that I get 22.2 repeating degrees. 22.2 degrees. Don't forget your units, Celsius down here. Again, very close approximation. All right, what about this one? 6 items purchased at a grocery store weigh 14 kilograms. One of the items is detergent weighing 720 grams. What's the total weight in kilograms of the other 5 items? Okay, well, I've got kilograms and grams, so I'm going to have to convert either all in grams or all in kilograms so I can, combine these weights. And since I want to leave my answer in kilograms, maybe I'll just change this grams to kilograms. So, King Henry dance merrily down Center Main, except if we're in grams, the only difference is, instead of meters, that's grams. All right, and I'm going from grams to kilograms. So 1, 2, 3. 1, 2, 3. So this is 0.72 kilograms. All right, let's reread the problem. 6 items were purchased at a grocery store that weighed 14 kilograms. One of them weighed this many kilograms. What's the total weight of the other 5 items? Well, obviously, if I take 14 and I subtract 0.72, 14 kilograms minus 0.72 kilograms gives me 13.28 kilograms for the weight of the other 5 items. What about this one? The prescribed, I'm sure that's supposed to have a D there, the prescribed dosage of a drug is 15 milligrams per kilogram daily. Meaning, oh, they're even going to tell us what it means. Great. Meaning that 15 milligrams of the drug should be administered daily for each kilogram of a patient's weight. How many 200 milligram tablets should be given each day to a patient who weighs 120 pounds? Okay, so we need to give 15 milligrams per kilogram of weight. So the first thing I need to know is, well, how many kilograms does this person weigh, right? So let's convert our 120 pounds, and because it involves the English, I'm talking about dimensional analysis, to kilograms. And I know my conversion factor is 1 pound is 0.45 kilograms. Okay, so 120 times 0.45 gets me 54 kilograms. Okay, so a person weighs 54 kilograms. Now, he needs 15 milligrams for every kilogram. If he weighs 54 kilograms, he needs 15 times 54 milligrams, 810 milligrams is the amount of drug he should be given. If your tablets contain 200 milligrams, right, then I need to divide this by 200 milligrams to get about 4, right? Specifically, 810 divided by 200, we get 4.05, 4.05, but I don't think you can give a 0.05 piece of a tablet, so they should be given 4 tablets to get the required medication needed. Okay, not only does that finish this section, it finishes chapter 9. Awesome. Let me know if you have any questions.